Recording in progress.
Let us discuss some problems on the irrational numbers, exercise 1.3. In the sixth problem, rational numbers having terminating decimal representations. Can you guess what property Q must satisfy? Okay, the total question is, look at several examples of rational numbers in the form P by Q. Q is not equal to 0, where P and Q integers with no common factors other than 1 and having terminating decimal representations, that is expansions. Can you guess what property Q must satisfy? Here we can take some examples. The rational numbers can expressed in the form of P by Q, where P and Q both are belongs to Z and Q should not equal to 0. In this, I am taking some examples: 1 by 3, 1 by 7, 1 by 6, 1 by 9, 1 by 11. Observe in the denominator, if 3, 7, 6, 9, 11, these are non-terminating and recurring decimals. Already we discussed in previous classes, if it is 7 is there, it's non-terminating, the number has the bar in the same way. If the the rational number is 1 by 2, it is equal to 0.5. So 1 by 5 it is 0.2. 1 by 10 means it's 0.1. Okay. 1 by 400 it is also we discussed in the previous problems. So these are just we can observe these problems or these numbers. These are clearly terminating. 1 by 5, 1 by 2, 0.1, somewhat number. It's clearly terminating. So you observe it in the denominator, either 2 or 5 or 2 and 5. Those numbers are in the denominator which are terminating. So what we can write it as, the prime factorization of Q is expressed in 2 or 5 or 2 and 5 only. That is Q in the form of 2 power n 5 power m form, where n and m are positive integers. This expression will come in the 10th standard. Okay. So this is same as it is. If in the case of 2 power 0, 5 power m, which can expressed in the 5 power m only. We know that something x power 0 equal to 1 from the exponents and powers. If 2 power n 5 power 0, it is clearly in the form of q equal to 2. If somewhat 2 power 1 5 power 1 means this is in the form of 2 and 5. You should remember, if it is terminating rational number, in the denominator value is either 2 or 5 or 2 and 5 of the powers only. 5 of powers only. Or we can write it as expressed in power of 2 or 5 or 2 and 5 only. Okay. This is the sixth solution. Seventh one, write 3 numbers whose decimal expansions are non-terminating, non-recurring. When it is non-terminating and recurring, that is related to the rational number. The rational numbers are two types. One is the terminating, another one is the non-terminating recurring decimals. Which are non-terminating, non-recurring decimals expansions, simply it is irrational. Irrational means not repeated. Okay. So we can take one is the 0.10, Here you observe it. 1 after 1 0 come, 1 after 2 zeros, 1 after 3 zeros, 1 after 4 zeros. It's not repeated. So this is a non-recurring. In the second example, I am taking 2 digits after 2, 1 digit after 2, 3 digits after 2. It's not related to the any repeated values. So it is also non-recurring. And here third one, I am taking 0.012001230. There is no relation, no repeated numbers. So such numbers, such are the non-terminating, non-recurring decimal expansions. Okay. You should remember, rational numbers are in the two forms. One is terminating, another one is non-terminating, recurring. irrational numbers only expressed in non-terminating, non-recurring. It is very, very important for MCQs. Next, eighth question. Write three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. We can take A is equal to 5 by 7 and B equal to 9 by 11. Suppose on the number line I am taking roughly, it is equal to 5 by 7, this is equal to 9 by 7. Average of these two, this is the, suppose one value, this is 5 by 7 plus 9 by 11 by 2 average. Next, in between of these two means middle value in these two. So let it be x1, x2, x3. For that case, I am taking first the average value xab or x equal to 5 by 7 plus 9 by 11 average by 2. A plus b by 2, a equal to 5 by 7, b equal to 9 by 11 by 2. Taking the LCM, 1 by 2 into 55 plus 9 7 is 63 by 7 11 is 77. 818 by 2 into 77. 2 ones are 2 5s are 2 9s are. So 59 by 77 is the x value. Okay. Next, this is equal to 59 by 77. Then we are taking A and x mean. Mean means average. That is x1 equal to A plus x by 2. A equal to 5 by 7. X equal to 59 by 77 by 2. It is equal to, taking the LCM, 77 is the LCM, 7 11s are 5 11s are 55 plus 59 by 77. Add these two, 114 by 2 into 77, 2 1s are 2 5s are 2 7s are 57 by 77. Okay, this is 57 by 77. This is the 59 by 77. You take something 63 by 77, or you take another one, B and X mean. Let it be x2. x2 equal to B plus x by 2. 1 by 2 into what is B value? 9 by 11. X value is 59 by 77. What is the LCM here? 77 is the LCM. Okay. 11 sevens are 77. 9 sevens are 63 plus 59. Then 1 by 2 into adding 9 plus 3 12. 122 by 77. 2 ones are 2 6 are 2 ones are 61 by 77. What are the three rational numbers? The three rational numbers one is 57 by 77, 59 by 77, 61 by 77 are between 5 by 7 and 9 by 11. This is the solution. It is the last question in this chapter, ninth one. Classify the following numbers as rational or irrational. Again I am saying, what is the rational difference, irrational difference? Rationals are two types. One is terminating decimal expansion, another one is non-terminating recurring. Non-terminating recurring decimal expansion. Irrational numbers means only which can expressed in the one form, non-terminating, non-recurring, which is non-terminating, non-recurring. You should remember, don't forget, don't confuse. Here you see, is it irrational number? The given number is irrational or rational? First of all, you identify that. The first question, root 23. What is the irrational number set and rational number set? That is also you have clear idea. The irrational number set which is in the P by Q form, such that P and Q belongs to Z and Q is not equal to 0 form. And irrational means the set form is root n, where n is not a perfect positive, not a positive perfect square, not a positive perfect square. Okay, 23 is a prime number which is not a perfect square, so it is irrational number. The expression in the under root, what is the number? The number is prime number, then it should be non-rational, that is irrational number. Why? 23 is a prime number. So, if the under root has prime number, clearly it is irrational number. Next, second one, root 225. This you take the prime factorization, 5 4s are 20, 5 5s are 25. 5 9s are 45, 3 3s are 9. So we can write it as under root of 15 square, square and root cancel, it is equal to 15. 15 is clearly rational number. This is equal to rational number. Okay, why? This can expressed in the form of P by Q, Q equal to 1. The third question, 0.3796. This is clearly terminating. We write in the form of P by Q. The decimal point after 4 digits are there. We take 1 after 4 digits, 4 zeros. So which is in the form of P by Q. It is clearly rational number. Next, fourth one, 7.478478. Observing that number, it is repeated 478, 478, so on. That is 7.478 bar. What is this? Which is, or it is 7.47 bar is non-terminating, recurring decimal expansion. So 7.478478 is a rational number. It is a rational number. It is also, you can write it as, it is a terminating decimal expansion. It is a terminating decimal expansion. So we can write the given number is a rational number. Next, fifth one, you observe it. The decimal expansion, is it repeated or not? 0.10, 100, 1000, 10000, so on. It's not repeated. It is non-recurring, non-terminating, non-terminating, non-recurring decimal expansion. So 0.10, 100, 100, 1000 is irrational number. Okay. By observing the numbers only, we can say that is it rational number or irrational number. If the number is terminating and repeated, non-recurring repeated, that is rational number. The number is not repeated, that is non-terminating, not recurring, it is irrational number.